Hey, welcome back to the lecture. So in this lecture, let's understand SPI hardware and behind the scene operation. So in this lecture, basically, we are going to explore how exactly the data communication takes place between master and slave, how they exchange the data. So let's see. So whenever you explore the SPI peripheral of your microcontroller, you always see shift registers. You will actually see one shift register in your SPI peripheral. So there is a shift register. So SPI communication is based on shift registers. So it's a very simple technique of data exchange, and I will explain you this with an animation. So let's say there are two devices. One is master and another one is slave. And the master SPI peripheral has one shift register of 8 bits. And this is the LSB and this is the MSB. And slave also has one shift register. And you can see that the MOSI of master is connected to MOSI of slave. The clock pins are connected, and the meso of slave is connected to the meso of master. So this is a connection. All right. You know that SPI is synchronous serial communication protocol, right? So clock is required to send the data or push the data. So this is a serial clock, so on which the data communication is synchronized, and this clock is going to be produced on the serial clock pin. All right, let me erase everything. So let's say our goal is to send the data which is there in the shift register to the slave. So now let's say we have this data A0 to A7. So first what happens is after one clock cycle, so A0 which is there in the LSB is actually moved out of this MOSI and it reached the MSB position of the slave shift register, and the data is moved by one step. So that's why the last data, which is B0, actually moved out of meso line, and it actually came and settled to the MSB position of the master shift register. So that means for every clock cycle, so there will be a shift in the shift register, right? So that is the principle of shift register, right? So if you can recollect from your basic electronics, so shift registers position shift for each clock cycle, right? So if you want to see one more time, I will show you that. So after one clock cycle, so A0 is moved to slave, and the B0 is actually moved to master. And after second clock cycle, you can see that A0 is moved by one position here, and A1 came to the MSB position, right? And after third clock cycle, A2 is moved, A3, A4, A5, A6, A7. So after the 8th clock cycle, the data which is there in the master's shift register is exchanged with the data which is there in the slave's shift register, right? So this is how the SPI communication actually takes place behind the scene. So, and also remember that by doing this animation, it is very clear that whenever master sends data, it also receives data, right? So this is the data which is received by the slave, right? So this is actually inevitable. So you will always receive the data if meso line is connected. Why? Because there is a shift. Whenever master sends data to the slave's shift register, so there is a data shift, and that shifted data will come over the meso line and it will settle in the shift register of master, right? So that's why inevitably you will always receive data if the meso line is connected. All right, so that's about the behind the scene operation of the SPI peripheral on your microcontroller. And in the next lecture, let's see customizing the SPI bus. So let's see what are the different configurations we can have on a SPI bus. I'll see you in the next lecture.